I used to be known as Professor PowerPoint until Microsoft's lawyers got a hold of me and they made me drop that. But my technology background actually led to an epiphany that I want to share with you. And every presenter always says how excited they are to be someplace. Well, I'm very excited to be here because I've been kind of living with this idea for about 7 or 8 years. And the idea is on the slide, so I don't really need to repeat it, but so much of this conference is about getting to the edge of science and making the leap towards consciousness. So here, I'm kind of preaching to the choir, because in this room, many people will be with me. Now, if you're not with me, I'll be happy to answer questions at the end and so on. But I think for the greater public and the population at large, it's going to be really important to open people up to the limitations of science. And my experience with software is really what I believe can be a tremendous factor in opening people's hearts and minds to the reality of the limitations of science and where it needs to go, which is really kind of the essence of this conference. Let me ask you a question before we even start. How many of you have ever seen computer code? Have you ever? You have, a couple, 3. So you've probably seen a web browser, like you've opened up the view source area of a web browser and seen the code in there? Anybody actually do any programming? You do? Okay. Wow, so I'm in trouble here because I'm a little bit over my head. But let me get started. So I want to talk about what software really represents. Software is really encoded intelligence. So let me advance the slides. And I really like facts. When I saw the pyramids, I was like struck by the reality that they are there, okay? And they were encoded intelligence. And we've had encoded intelligence as humans for many, many centuries. But what's different about software is that it's active encoded intelligence. It actually does something. And in fact, the way I got started with this whole idea was when I came to Los Angeles, I was going to be Steven Spielberg, but I discovered that position was already taken, and I had to get a job. And I worked for a law firm, and I worked for a law firm, and I had to learn word processing on their own IBM system, which is about as big as this table. And they handed me about 6 big floppy disks. They're proprietary. They said, when you finish with these 6 disks, you'll be trained. And amazingly enough, it just blew my mind. This machine trained me. This was like almost 30 years ago, before all the personal computers that we know today. And it just changed me because all of a sudden I realized that there was intelligence, active intelligence, present in this machine. And that started the ball rolling for me in terms of what really brought me here today. And then about a week, what happened in that software thing was I encountered my first bug. And here's a bug that I found at Big Bear a couple of weeks ago. And I had another epiphany with this, because I realized that this fly was running the same operating system that I am. Because my point is that DNA is actually software. It's not a metaphor for software. Okay? And I'm going to show you a video now, which is why I really wanted the slides to work, because geneticists have actually discovered this. They don't talk about DNA as like software. They actually talk about it as being software. So I want to play the short video. It's by a geneticist. His name is Juan Enriquez. It was a TED video. And I want you to listen carefully to how he describes DNA and how he uses it as a floppy disk and what's happening with this animal that you see on the screen.
This is a baby gar. Conservation group gets together, tries to figure out how to breed an animal that's almost extinct. They can't do it naturally, so what they do with this thing is they take a spoon, take some cells out of an adult gar's mouth, cut it, take the cells from that and insert it into a fertilized cow's egg. Reprogram it. Cow's egg, different gene code. When you do that, the cow gives birth to a gar. That means each of you will contain, on a CD, your entire gene code. And it will be really boring. It will read like this. The really neat thing about this stuff is that's life. And Lori's going to talk about this one a little bit. Because if you happen to find this one inside your body, you're in big trouble, because that's the source code for Ebola. That's one of the deadliest diseases known to humans. But plants work the same way, and insects work the same way, and this apple works the same way. This apple is the same thing as this floppy disk. Because this thing codes ones and zeros, and this thing codes ATCGs, and it sits up there absorbing energy on a tree. And one fine day, it has enough energy to say, execute, and it goes, right? And when it does that, pushes .exe, what it does is it executes the first line of code, which reads just like that, ATCGA, and that means make a root. Next line of code, make a stem. Next line of code, TACGGG, make a flower that's white that blooms in the spring that smells like this. In the measure that you have the code, in the measure that you can read it, and by the way, the first plant was read 2 years ago. First human was read 2 years ago. First insect was read 2 years ago. First thing we ever read was in 1995, a little bacteria called Haemophilus influenzae. In the measure that you have the source code, as all of you know, you can change the source code. And you can reprogram life forms so that this little thing becomes a vaccine. Or this little thing starts producing biomaterials, which is why DuPont is now growing a form of polyester that feels like silk in corn. This changes all those. This is life. But we're reprogramming.
So we haven't created life, but we are reprogramming it. And when I saw that video, it really changed me because of the little bit of programming experience that I've had. Because let's look at what he said. He pushes .exe, and you all laughed, and executes the code just like it does in computer code. And that's life. So what does that actually mean? That's what I want to explore with you for a few more minutes while I have it. And I want to dig a little bit deeper into how code works and what the implications are, at least the way I interpret them. And probably some of you feel the same way. But it's extremely important because we all use computers every day. So I think this can all make an impact on people when they understand it. So here I put some HTML code on this side, and I put some sequence genetic code. This is the Ebola stuff that he was just showing in the video on this side. And you can see the similarity, but it goes much deeper. Because although I say DNA is software, probably more to the point would be to call it a programming language. And here you can see that both of these are languages. Syntax matters as much in the sequence DNA as it does in the web browser. A language implies, and I'm going to take this a little bit deeper, but language implies a mind and meaning. It's based on symbols. Code, any code, whether it's the cave drawings of Lascaux or the pyramids or computer code, is symbolic. And because it's symbolic, it conveys meaning. And anytime there's meaning, it's clear to me, and I think it would be clear to almost everybody, I don't understand any argument about it, that implies that there's a mind. And it doesn't matter whether that language is images, words, letters. The ACTG, as many of you may know, are the representations of sequenced DNA. Each of these represents a protein. So what we have is an organic programming language, working in protein, having meaning, and in my estimation, clearly suggesting the presence of a mind. And not only a mind, because if you compare DNA with HTML, the immensity of the intelligence behind it is enormous. So I want to go a little bit deeper. Maybe some of you are, as I asked originally, some of you have done some programming. For those of you who haven't, this is simply a macro. This macro will make a red square in a Word document if you press a button. When you press a button, it's exactly what Juan Enrique said in the video, where the sun inputs to the tree and the apple drops. Right? There's an input. The input makes a red apple. If you change the numbers of the RGB values, instead of a red rectangle, you'll get a blue rectangle. And again, software is encoded in intelligence, but it's active. And this takes me back to some stuff that came up yesterday with Deepak Chopra and with Rupert Spira, where they talked about life being an activity and not a thing. Software is a verb. It's like Buckminster Fuller said, I think I am a verb. Software does stuff. It's active, and humans have created it. But if it's active in DNA for 14 plus billion years, I'm not answering this question, I'm just posing it. Where did this come from? You can create red text in a web page. You can determine how it's going to display in a web browser. So again, if you change what's called the hexadecimal code in a web browser, and I'm getting a little bit more technical than I wanted to, but it's important to see how deep this goes. Because if you look at the ACTG sequence of DNA, it works exactly the same way. And so my point is you can copy and paste life. And the other example of this, and I won't belabor it because I've only got a couple of minutes, is that there was a thing on 60 Minutes where Leslie Stahl went and they found that they could copy and paste the DNA of an Arabian sand cat, which was almost extinct, into a regular house cat. And when the egg, they inseminated the egg, when the baby came out, it was an Arabian sand cat. They had copy and pasted DNA. They had copy and pasted, literally, life. If this doesn't touch you to the core and make you realize that life is running on an organic programming language or an operating system, I don't know how else people can continue to think that this is all random stuff. We've had some people talk about it. Even the atheist Richard Dawkins said that the machine code of genes is incredibly machine-like. Now, I'm not making an argument for intelligent design or creationism or anything like that. I'm just saying this is a question that science needs to address because this points directly at consciousness. When science tries to go through this, they just gloss over the fact that this is software. And how did life eventually create how did nature eventually create something that is intelligent without being intelligent? Intelligence can't come out of a swamp with a lightning bolt. In fact, this is a wonderful quote. I saw it at ION's conference. Fred Hoyle, as you know, is a famous astronomer, and he said that the chances of life beginning through accident are the same as a tornado going through a junkyard and from the pieces in a junkyard assembling a 747. The kind of immense intelligence that's obviously present in DNA code suggests something much more powerful. So I don't have the answer to this question. All right, well, so much for that. I don't have the answer to this question, but I think we've gotten to the really important stuff here. Good. So this, wow, it worked. So this reminds me of the first chapter of A New Earth by Eckhart Tolle. How many of you read that book? Okay, the first chapter was so beautiful to me because for millions of years, life was just lily pads, right? And then one day, it flowered. The DNA executed its code, and an entirely new level of reality appeared for this particular organic thing that we label a lily pad or a flower or a lotus, right? But it evolved to a new level. I think that when we understand the true nature of DNA and software, and this is the key point that I really want to make too. We've only had software for about maybe 50 or 60 years. So our experience with it is very short-lived. But now people, having used software, have the capacity to understand what it really means. And we can continue and we can understand that DNA is software, and essentially, so are we.